video will help you review the first fundamental theorem of calculus for the AP Calculus exam. The first fundamental theorem of calculus states that if little f is continuous on the closed interval from a to b, and big F is the indefinite integral on little f of a to b, then the integral of a to b of little f of x dx is equal to big F of b minus big F of a. Okay, so for this problem, we're trying to find the integral from -4 to -1 of f prime dx. I'm going to write that out here. Now we know that that integrates to f of x. So we're going to rewrite it like f of x, and then make a bracket and put the bounds in as -4 to -1. Now because of the first fundamental theorem of calculus, we know that to find your answer, you're going to plug in f of -1 and then subtract f of -4. Now we refer to the chart and see that f of -1 is equal to -1.5. Now refer to the chart again and see that f of -4 is 0.75. -1.5 minus 0.75 is equal to -2.25. So the answer to the problem, integral from -4 to -1 of f prime of x dx is equal to -2.25. Now, the answer to the question is B. So circle it. This problem was from the 1998 multiple choice exam. The first step is we're going to rewrite it like this. The integral of 1 to e of x minus 1 over x dx. The next step is to get the integral of this. So you add 1 to the exponent and then divide by that same thing that you added. So x squared over 2 minus ln of x. Now we're going to put a bracket here and put the bounds. So now what we're going to do first is plug e in. And now we're going to subtract that by 1 squared over 2 minus ln of 1. Okay, so we know that the ln of e is 1. This is just 1/2, and then the ln of 1 is 0. So e squared over 2 minus 1 minus 1/2, which is 3/2, minus 3/2. And here's our answer. So let's see. It's E.
This problem comes from the calculator section of the 2007 free response. So what we're given is a graph that shows the velocity of a particle that moves along the x-axis, and it's given by the function vt equals sine of t squared. So for this question, we're asked to find the total distance traveled by the particle from time equals 0 to time equals 3, which is about here. So what we want to do is find the total distance from 0 to 3. Now, what we could do is just simply take the definite integral of 0 to 3 of sine of t squared. However, that would only account for all the positive velocity and not the negative, which is also distance traveled even though it's going the opposite direction. So instead what we can do is we can still go from 0 to 3, but instead of just taking the integral of this, you'd want the absolute value of sine of t squared, which will give you the total distance of the particle throughout the entire time frame. So since this is calculator section, you can plug that simply into your calculator and you get 1.7024, and then you want to round to 3 decimals, so 1.703.
Actually, you made a small rounding error and it rounds to 1.702.
Can we still use that?
Yeah, we're using it.
This problem is from the no calculator section of the 2010 free response. So what we're given is a graph of g prime, and then the value g of 0 equals 5, and we're going to be finding g of 3 and g of -2. So we're going to start off by saying that g of 3 is equal to 5 plus the definite integral of 0 to 3 of g prime of x. So then we're gonna do 5 plus, so now you're taking the area under the curve from 0 to 3, so it's gonna be pi times 2 squared, because that's the radius, over 4, because this is 1/4 of a circle. So it's pi r squared, which would be the area of the full circle, divided by 4. And then plus the area of this triangle, which goes to 3, which is going to be 3 halves. So then it's going to be 5 plus pi plus 3 halves, which is then going to be equal to pi plus 13 halves. So that, all right. So then we're going to do g of -2, which is a little bit different just because it's a negative number. So it's going to be 5 plus the definite integral of -2 to 0 of g prime of x. And so because we usually go from left to right, we can just switch the sign. So it's 5 minus the definite integral of -2 to 0 of g prime of x. So that's going to be 5 minus the area of this quarter of the semicircle, which as we know from before is just pi. So then g of -2 is going to be 5 minus pi.
This problem comes from the 1998 multiple choice section of the calculus exam. So what we're asked to do here is to find the definite integral from 1 to 2 of 1 over x squared. So to start, we can rewrite this as x to the -2 dx and take the integral of that. Then when you integrate, you add 1 to the exponent and divide by that new exponent. So you get -1x to -1 from 2 to 1. We can then rewrite that as -1 over x with the bracket, and then we can simply plug in 1 and 2. So you do -1 over 2 minus -1 over 1, which really just goes to -1/2 plus 1, and you get +1/2. So the answer is C.
All right, so this problem is from the no calculator section of the 2006 free response exam. So we're given a graph of the calories per minute that a person burns when they're on an exercise machine. And so we're gonna find the total number of calories burned over the time from 6 to 18 minutes. So basically we're just gonna be doing area under the curve. So it's going to be the integral from 6 to 18 of f of t is equal to, so this rectangle is gonna be 6 by 9. Plus, this is gonna be a trapezoid, so it's 1/2 times 4, which is this base length, times the 2 heights, which are 9 plus 15. And then this rectangle is just gonna be 2 by 15. And so then once you multiply all that out, which I suppose I can do, 54 plus 2 times 24 plus 30 equals 84 plus 48, which is equal to 132 calories.
Here, I'll actually do my problem. Right?
Here's our lefty, Kyle. He's a star math student, pre-med at UConn.
You're not.
You're not putting that in,
You're not putting
Avery.
No, you're just gonna take a video and
What?
Not because we say this, it comes naturally, so we're actually gonna have no friends at college. Everyone's gonna think that.
Big F of B minus big F.
What was that doing?
That was literally the last thing she did.
Literally big F of that.
Big F!
You're fucking staring at me. While I'm reading it.
Where is... Follow my mother!